In this video, we'll look at an example of sketching a parametric equation and then also finding the slope of a tangent line on that graph and arc length on the graph. So for this example, we'll look at the parametric equation x is equal to -2 plus 3 cosine theta, and y is equal to -5 plus 3 sine theta. And we are going to look at theta in the interval from 0 to 2 pi. And so I like to make a table of values for these points. And for theta, we'll do 0, pi over 2, pi, 3 pi over 2, 2 pi. And those typically how you would divide that up. And then these, the way we fill in the table is just -2 plus 3 times cosine of theta, or it would be cosine of 0, is going to give me the point 1. So I just want to put one last column over here, x and y. And so my x value will be 1, and my y will be -5 plus 3 sine theta, or 3 sine of 0. Which will give me 0. So this will be the point 1, -5. And for pi over 2, so again, I'm just going to fill in -2, 3 cosine pi over 2, -5 plus 3 sine pi over 2. And so this will give me a point -2, -2. So I'm going to just follow down, filling in these points, and the points I'll be left with here at pi, it will be -5, -5. At 3 pi over 2, it's -2, -8. And at 2 pi, it's 1, -5. And so when we're graphing these points, we want to graph these in order so that we get the correct orientation. So starting off at 1, -5, and then at -2, -2. So we're moving in this direction. That's what we call our orientation. And then -5, -5. Oh, I guess got the concavity of that wrong. -5, -5. So we're going this way. And then -2, -8. And then back to 1, -5 again. And so that kind of looks like a football, but it's actually a circle. So that's my parametric equation. And to get the Cartesian equation out of that, we'll take, let me just write x is equal to -2 plus 3 cosine theta. So this means that x plus 2 divided by 3 is equal to cosine theta, and y is equal to -5 plus 3 sine theta. So y plus 5 divided by 3 is equal to sine theta. And then if we use our equation for a circle, x minus h squared plus y minus k squared is equal to r squared, we can substitute in cosine squared x plus sine squared x is equal to 1. So this is going to give me x plus 2 over 3 squared plus y plus 5 over 3 squared equals 1. I'm just going to multiply both sides of that equation by 9, and I'll have x plus 2 squared plus y plus 5 squared is equal to 9. So this becomes a circle centered at -2, -5 with a radius of 3. And so if you look at what we drew here, that's exactly what we have. At -2, -5 is the center of our circle, and we have a radius of 3, r equals 3. Okay, so let's say we wanted to find the slope of the tangent line at the point t equals pi over 4. So when t is equal to pi over 4, we can substitute that in. X would be equal to -2 plus 3 cosine pi over 4. And my y would be equal to a -5 plus 3 sine pi over 4. And just to give you an idea of where that point is, that's going to be the point 0.12 and -2.8. So that is about right here. In a different color. So we're going to find the slope of the tangent line at that point. And the way we do that is dy dx will be equal to dy dt divided by dx dt. And so if we look at what our equation is, the slope of dy dt will be equal to 3 cosine theta. And the slope of dx dt will be equal to negative sine theta. And so 3 cosine of pi over 4 over -3. Well, why don't I just do this? That gives me negative cotan of pi over 4, which will equal -1. So that's my slope of my tangent line at this point. And then the other thing that we can do is to find an arc length on this graph. So let's say we wanted to find the arc length in the interval 0 to pi over 2. And so we're using a formula similar to what we've seen before. The arc length will be equal to the integral from 0 to pi over 2 of the square root of dx dt squared plus dy dt squared. And so in this case, our dx dt, so this is going to be equal to the integral from 0 to pi over 2 of the square root of dx dt, which we have here, is -3 sine theta squared plus dy dt, which is 3 cosine theta squared d theta. Should put d theta here. Okay, and so that's going to give me s will be equal to the integral from 0 to pi over 2 of the square root of 9 sine squared theta plus 9 cosine squared theta d theta. And so that will be equal to we can pull out the 9, right? We can, let me just do this down here. 9 times sine squared theta plus cosine squared theta. So that is just going to equal the integral from 0 to pi over 2 of 3 times 1 d theta. So d theta. So that will be equal to 3 times theta. And we'll evaluate from 0 to pi over 2. And that will be equal to 3 pi over 2. Okay, and that makes sense because we have a radius of 3, so we're just expanding that circle by 3, so the arc length from 0 to pi over 2 would be 3 pi over 2.